Good afternoon, everyone. Thank you for joining us today for the Intro to Efficient Lighting and Controls webinar. My name is Beth, and I'll be hosting this afternoon's webinar. We'd like to start off with a safety moment. Safety is a core value at PGE, and we would like to remind you to be safe around electricity. As you consider installing or retrofitting new equipment, please keep safety in mind. We would also like to encourage your family and staff to be prepared with an outage kit, and you can visit our website for more safety information. That's at portlandgeneral.com/safety. We would also like to thank the Energy Trust of Oregon and the Northwest Energy Efficiency Alliance for their support in co-sponsoring this series of free energy efficiency trainings that are open to all Northwest utilities and their customers. Before I introduce the presenter this afternoon, I'd like to show you some tools you'll be using during the webinar. To the right of your screen, you'll see the chat window, and a polling window will appear at the end of the session. If you have any questions during the webinar, you can submit them through chat to me, the host, and I will ask them of the presenter at the end of the session. At the top left corner of your screen, underneath the Quick Start menu, you'll see several tools, which I will highlight here in red. You'll see an arrow tool, a text tool, and a marker, and the presenter will ask you to use these on specific slides during the webinar. And now I'd like to introduce this afternoon's presenter. Mark Whitney is with PGE. He's our lighting specialist. For the past 16 years, Mark has been active with the local Oregon section of the Illuminating Engineering Society of North America, which is widely recognized as the lighting authority. Mark has a long history of providing lighting education to professionals and has instructed all levels of lighting courses offered through the IESNA, as well as lighting classes offered for PGE customers and employees. As a lead accredited professional, Mark is familiar with sustainability issues, particularly issues that relate to lighting. Mark is lighting certified from the National Council on Qualifications for the Lighting Professions, and he received a BA in Business Administration from Carthage College, Wisconsin. And now I'd like to turn the presentation over to Mark. Mark?
Thanks, Beth, and welcome everyone to today's Efficient Lighting webinar. My intent is that you'll find today's presentation both helpful and useful. So one of my favorite things to do at PGE is working with our commercial and industrial customers to help them with their lighting efficiency projects. And I plan to share some of my favorite tips and suggestions with you today. So on your screen is today's agenda. The main themes throughout the day will be saving energy, saving money, and providing better quality lighting through a lighting upgrade project. So throughout this webinar, if you could think of a lighting upgrade application at your place of business, or just pick one that you're interested in, and that will be helpful in following along this afternoon. So the goal today is to supply you with information about lighting and energy efficiency that will make a difference at your place of business. So I'll start with some lighting basics and then quickly move on and show you how to apply this information for your particular project. So we invite your active participation today, and one way is by using the annotation tools that Beth talked about that are on the upper left-hand side of your screen, and an arrow or the drawing tool seems to work the best. In fact, I'll ask you to use these tools on the very next slide. And then we plan to leave about 10 minutes or so at the end to answer any questions. These are the key learning objectives for today. So if you would, to help me out here, please use one of your annotation tools to indicate to me which one of these are of the most interest to you. So during the early part of the presentation, we'll focus on how to get light to the work plane effectively and efficiently. And then throughout the presentation, I'll share several energy-saving lighting upgrade applications. While the focus will be on retrofit, new construction will apply also. Toward the end, we'll go over how to save energy with controls by focusing on occupancy sensors. And after we've learned a few things today, I'll let you know how you can get help with your lighting upgrade project. And it looks like most of you are interested in applications and controls. All right, thank you. So we'll start at the beginning, which is defining what light is. Essentially, light is radiant energy that we can see. And light is light whether it's from the sun, fire, or electric light sources. However, there's many variables about light, and we'll discuss a few of these today. And normally, we're looking at reflected light, unless you're a lighting geek like me that's looking up all the time. And our eyes were designed to be sensitive to this energy. So what is visible light? Well, it's part of the electromagnetic spectrum that we can see. It's radiant energy, but it's a very small band of visible light that our eyes are sensitive to, from about 380 up to around 780 nanometers. As you can see, all the colors of the rainbow are present. So light quality is very much related to the amount and intensity of the light spectrum in a particular light source. So our eyes were designed to detect visual images on the retina on the back of the eye. And we have photosensitive receptors that allow us to distinguish color and light intensity. So we have rods which help us distinguish between different light intensities at lower light levels, and they're scattered throughout the back of the retina. And at low light levels, we have very few color cues. Color cues come from the cones, and these allow us to distinguish color at higher light levels. It's important to know that most of these cones are located in a small area of the retina called the fovea. And this fovea represents about a 2-degree view of vision. This is our optimum vision, where we can really focus. And that'll be important, as we'll find out later on. We'll talk about 2 color metrics. The first one we'll talk about is the Color Rendering Index, or CRI. And this indicates the effect of a light source on the color appearance of objects. And there are 8 color samples that are rated and scored for accuracy. And this is a 0 to 100 scale, with 0 being the worst and 100 being the best. In other words, it's a perfect match. So the sun would be an example of a perfect 100, and for electric light sources, incandescent are usually very close to 100. And this is why, even though incandescents and halogens are not very efficient, they have very poor efficacy, they still render colors very well, and that's why you still see them being used. High pressure sodium, on the other extreme, is an example of a very poor color rendering, maybe around 20 or so. And it's also very yellow, which is one reason why a lot of cities, including Portland, are switching their high pressure sodium to LEDs that have a much better color rendering index and long life and a lot of other benefits. So a CRI of 85 is considered to be very good, and you'll get that with your better quality fluorescents. However, keep in mind, you don't have to have real high CRI for every application. If you have a retail store, art gallery, or museum, yeah, you definitely want to have a really good CRI. But if you have a warehouse and you're just storing some stuff, maybe not so much. So you can often save some energy by not having to have some higher CRI products, especially in LED that tend to be a little bit more expensive and use more energy. So the other metric we want to talk about is correlated color temperature. And this is measured on a scale called Kelvin, and it's represented by the letter K. And color temperature indicates the relative warmth or coolness of a light source. For 3200 K or less, that's considered to be warm. It's on the red side of the spectrum, while 4000 K and above is considered to be a cool source and has more blue in the spectrum. So choosing your color temperature is very subjective. Most people's skin looks better under warmer sources, and the reason for that is that there's more red, and it just tends to look better with people. However, we see most tasks better under cooler sources. And one reason for this is that when you have more blue in the spectrum, it helps make our pupils smaller, which allows us to see more clearly. If you remember a couple slides ago, we talked about the fovea and how the cones are in that 2-degree field of vision that allow us to see really clear. So the rays that come in, the images that come in outside of the fovea aren't very clear and don't help us in acuity all that much. And higher color temperature lamps may also allow for energy savings for certain applications. So this will be a good slide to use your annotation tools again, so get those at the ready. As you can see on this graph, the larger the number, the cooler the light source. And all sources have a range of color temperature. So for incandescent and halogen, for instance, down here, you'll see that they're between 2700 and 3100 or so, whereas your fluorescent sources have a range from below 3000 up to 6500, and actually even above, you can get a higher color temperature in fluorescent. So what color temperature, thinking of your application that you've chosen for today, what color temperature is your preference for your application that you're thinking about or getting information about? So use your arrow tool or your line to indicate what your preferred color temperature is. So fluorescent sources, they can vary their color temperature by adjusting the mixture of phosphor that is used to make white light. Although all phosphor appears white, there are variations in the phosphors that transform light either warmer or cooler. And that's one reason you can have this wide range of color temperatures with fluorescent, which makes it a very versatile lamp. So looking at your choices, we have 3500, but then we also have some that are much cooler. So it looks like most of you like the cooler temperatures for your application. So thank you. So let's turn our focus now on some common lighting terms, and then also how to get light where you want it in an efficient way. So doing that begins with a light source. Now to light a light source, to have it energized, you need some input power. That's known as watts. And the result, hopefully, if the bulb is working, is that you get output in lumens. And the efficiency of a light source is better known as efficacy, and that's stated as lumens per watt. So for a point of reference, your incandescent bulb you're looking at might be around 15 lumens per watt, where a good fluorescent could be around 100 lumens per watt. So this is where we want to start. We want to start with a source that has a good efficacy, high lumens per watt. And then we want to now then get that light to the work plane in an efficient manner. And the more efficient we can do that, the more energy we can save. And a good efficacy rating is a good place to start. So to help further your understanding of efficacy and how the different light sources compare to one another, put this chart together which shows the different efficacies and the range of efficacy that some sources have. So in the upper left, we have your incandescent and halogen, which are the worst, but they have good color rendering, so we still use them. So you can see, you can get pretty good when you get into halogen infrared, and that could be a good choice for some applications, especially low hours of operation, or if you want dimming. When you get into your compact fluorescent, you see a pretty good jump. Any of the compact fluorescents, even the worst, are better than the best incandescent. When you get into linear fluorescent, you're going to see that the T8s and the T5s, any of them, are better than even the best T12. One thing you're going to notice here with metal halide, and especially light-emitting diodes, is that there's room for improvement. With metal halide, they're doing some some research and some innovations that are getting the efficacy higher, but we're seeing the biggest jump in light-emitting diodes. It seems every month we're getting better and better efficacies, and they think that it could peak out even up to 200 lumens per watt someday. So remember, efficacy is just the starting point. Next, we want to see how choosing fixtures can allow us to get the light to the work plane the most efficiently and the best. Sometimes the most efficient isn't the best. So electric light sources are going to be housed in some sort of luminaire or fixture. So picking the right one is going to be very important. So luminaire efficiency is the ratio of the lamp lumens leaving the luminaire relative to the lumen output of the lamps going into the luminaire. This is expressed as a percentage. So for example, this one lamp strip fixture is 95% efficient. That means that 95% of the lumens given off by that lamp actually get into the room where you want the light to go, as opposed to this 3-lamp parabolic fixture that is only 65% efficient. That means that 35% of the light given off by the lamps never even leaves the fixture. It's getting absorbed by materials, it's being reflected and bounced around, never gets out. So one way that you can improve this parabolic is to replace the parabolic lens and put an advanced lens on there that is more efficient, and you could get that efficiency up from 65 to maybe even 85%. So that could be a huge savings there. So in general, the more light control, the lower efficiency. Keep in mind that sometimes you want that light control to reduce glare or to direct the light where you want it to go. So let's go into this a little bit deeper and expand on this topic of efficiency and getting light to the work plane by knowing that some of the light rays coming out of a lamp and a fixture go directly to the work plane, while others are going to bounce around off the walls, the fixture components, objects in the room, so that you're going to have some light that's going to be lost through reflection, and you're going to have some light that's lost by absorption. And all objects are going to absorb some light to some degree. And if you have a semi-transparent material like you have in this particular illustration, you're going to have light that's going through, and you're going to be losing some of that light going through that semi-transparent material. Even clear glass, you're going to lose some. But the more opaque that the semi-transparent material is, the more light loss you're going to have. So why are some fixtures more efficient than others? Again, we lose some light every time it strikes a fixture surface or goes through a material like a lens. So would changing the color of the walls and ceilings make a difference in getting light to the work plane? Absolutely. Light is also going to reflect off walls and objects in the room before it gets to the work plane. So others take an indirect route, while others are going directly from the lamp to the work plane. So you can improve your efficiency by painting your walls and ceiling a brighter color. So foot candles, I want to talk about this. They represent the average amount of light spread over a work plane surface. So it's the amount of light from one candle, 1 foot distance, 1 square foot in space. So it's very important to know also that light levels are greatly affected by distance. So even though here we have 1 foot candle 1 foot away, when we go 2 feet away, we don't have 1/2 of a foot candle, we have 1/4 of a foot candle, and that's because light is affected by the distance squared, not just the distance. So as you get out even further, that light gets spread out over a larger and larger surface. So what is the work plane? So the work plane could be horizontal like your desktop or the floor, or it could be vertical like a whiteboard or maybe a retail display. So how much light do you need? What's a good point of reference? Well, the IES has some categories here that'll help us out. So for simple orientation, just getting around, simple visual tasks, less than 1 foot candle up to 20 foot candles would define that category. Your common visual tasks, like reading, are going to be from, say, 30 to 75. But then you have special visual tasks like inspection, brain surgery. So that category goes from around 100 foot candles up to around 2,000 foot candles. Keep in mind that a lot of applications are overlit, so that there are opportunities to save energy when retrofitting by adjusting light levels lower. But that's not always the case. In case you've never seen a foot candle, here's what one looks like. All right. So now we finally got our light to the work plane, and that's great. That was our goal. But there's a couple more things we need to think about. One is, what happens to light over time? Sure, light fixtures are great and the lamps are bright right out of the box when you fire them up. But over time, every light source loses some light output, and some a lot more than others. You're going to see the T12 here, besides having a short lamp life, it can lose 30% or more of its light over time, whereas your better T8 and T5 lose less than 10% over time. So that can really make a difference in how you design a space. Now here's a real spaghetti graph, but the point of this is, here's that 90% line we'd like to have our light sources stay above. But so many of these light sources we have today, especially some of your 8-foot HOs and VHOs, they really depreciate rapidly, besides having a very short lamp life. Metal halide and mercury vapor, they also have a very steep depreciation curve on there. So one of the main points here is, because of that depreciation, you either overlight a space by quite a bit to allow for that depreciation, so that you don't have too little light when the lamps are depreciated, or you just put up with the light loss over time. And there's people that do both things. So also keep in mind, besides the lamp lumen depreciation, there's other depreciation factors like dirt in the fixtures and on room surfaces, for instance. So one more thing that we're going to talk about is spacing criterion. And this is the ratio that's used to calculate the maximum recommended installation spacing to obtain an even pattern of light. So for your ambient lighting, this is usually the goal, is you want a nice even pattern of light. You don't want some real bright spots and then dark spots. You want it as even as you can. And having the right spacing is going to be very important for that. And just to give you a heads up, there's going to be a 1-question quiz on this slide, so get your annotation tools at the ready. So how do you find this number? The spacing criterion can be found on a fixture specification sheet, and it's going to be unique for each fixture. It'll have a different number. Now in this example, the spacing criterion we found for these particular fixtures was 1.1. So to do the simple math, 1.1 times 10 feet, our ceiling height, means that these fixtures shouldn't be spaced any further apart than about 11 feet to give us that even illumination. We want that nice overlap. So let's say, again, here's the quiz. Let's say the spacing criterion instead of 1.1 was 1.2. So now, how far apart should the fixtures be spaced? And to help you out, we've got 3 choices. So this criterion applies to relatively open spaces. So if you had a lot of high cubicle walls or partitions, you might want to have the fixtures spaced a little bit closer together. So proper spacing can save energy by not having fixtures too close together. Thank you for your answers. 12 feet was the right answer. So in this next section, we're going to discuss two common lamp families, incandescent and fluorescent. But first I want to go over some lighting terms that help us describe lamps. And unfortunately for maybe some of you, this involves a little bit of math. So when you have a lamp designation, there'll be a letter, and that letter designates the relative shape of the lamp, while the number that follows designates the maximum diameter of the lamp in eighths of an inch, which is where the math comes into place. So we'll use a easy example first. So with a T8, the T stands for tubular, and the 8 is 8/8 of an inch, or 1 inch. So with a T8, you have a tubular lamp that is 1 inch in diameter. With a T12, it's going to be 1.5 inches. With a T5, it's going to be 5/8 of an inch. Over here we have a G, stands for globe, and it's 30/8 of an inch, or 3 3/4 inch in diameter. So I think hopefully you get the gist of that. So we're going to start our lamp family discussion with incandescent, and we'll talk about some alternatives, and we'll spend some time on this because it also has a lot to do with comparing very inefficient with efficient sources in general. So incandescent bulbs have not fundamentally changed since they were invented by Thomas Edison about 130 years ago. So why are we still using them? Well, one is that they're inexpensive. You can get them anywhere. People know how to use them. They can change them when they burn out. As we saw before, they have an excellent color rendering. And probably the most important thing, or one reason they're still around, is they're easily dimmed. But they do have some very big disadvantages. The efficacy is very low. There's more energy to heat than light. Lamp life is short. And it's such a bad source that we've actually come up with some laws that don't explicitly ban incandescent, but the efficacy hurdles are too high for most of your basic lamps to meet. So in this next discussion, keep in mind that halogens, when we use that term, is another type of incandescent lamp, but they perform better than other types of incandescents. So there was a law passed in 2007, and it took effect January 1st of last year, and it affected your basic 100-watt bulb. So this year, 75-watt bulbs were affected, and next year, you won't be able to manufacture 60 and 40-watt bulbs. You can still sell them, you just can't make them anymore. So one way to look at your options is, and I put up here good, better, and best. And to help decide which you should choose to replace your incandescent bulb, here's a few things to look at. Here's lamp life. This one, the advantage definitely goes to LEDs, very long lamp life. First cost, the advantage goes to energy-saving incandescents. CFLs generally a little bit more expensive, and LEDs right now are fairly expensive, but in future editions of this presentation, I'm going to take off some of those dollar signs because the prices have been coming down pretty dramatically. Energy savings, you'll get the least savings with the energy-saving incandescents. CFLs and LEDs are comparable in their energy savings, but again, I would change this slide to probably 80% or more for savings with LEDs. As we mentioned, the incandescents dim well, the CFLs really don't. Same with linear fluorescence. With LEDs, it's a mixed bag. You can get good dimming, but sometimes you have issues like flicker and incompatibility with dimmers and so on. Excellent color rendering, we talked about that. CFLs, still very good, but it's not up there with your incandescents. And LEDs, even though there's a wide range, you can get very excellent color quality with LEDs. So that's important to know. So let's compare, and here's some examples from GE, Philips, and Sylvania, known as the big three of lamps. So the energy-saving incandescents still make sense for applications that have low hours of operation, where you want dimming, and very important for some applications, you want that warm color temperature shift that happens when you dim incandescents. You don't get that with fluorescent and most LEDs. Compact fluorescent is going to be for applications that have longer hours of operation, don't need to dim, and you also have infrequent switching. Fluorescents, CFLs, and linear fluorescent, the lamp life is shortened dramatically the more you switch them. LEDs, they're going to be best because of their first cost. They're going to be best for applications with very long hours of operation, and also where bulb replacement is expensive or difficult. LEDs can also dim, and they don't mind frequent switching. You can turn them on and off all the time, and they don't mind. So that's a real benefit. We're going to turn now to track lighting options. And until recently, there just hasn't been an acceptable alternative for halogen reflector lamps. CFLs were tried, but they really don't have a good beam pattern, and the quality of the light wasn't good enough for most applications. So compact metal halide lamps were one option, and they've been a reasonable choice, but they have shortcomings in their light quality and also their lamp life. So these screw-in LED replacement directional lamps, they've improved to the point where they're now an excellent alternative to halogens. This is one of the best applications for LEDs right now. They've got great energy savings, they have long lamp life, you can get them with a good color rendering, and they come in a variety of sizes and shapes, from your PAR 38s that we see in the upper left to the MR16 that you see over on the right. And you can get good incentives, cash incentives for these lamps from Energy Trust in our service territory. One thing to keep in mind is that even if these didn't save energy, just because of the long lamp life, it'd be cheaper to buy one LED replacement lamp at $40 instead of 10 halogens at $10 each over time. And think about the hassle of changing all those 10 lamps. However, they do save a lot of energy, and as you see, qualify for cash incentives, which after you apply those, the payback on changing these out can be 1 to 1.5 years. Now, if you want or need to change out the entire track head, then you can get a custom incentive for approved products for that. Okay, so let's move on to fluorescent. So T12s with magnetic ballasts. Most of the T12s in the 4-footers that you see now are not 40 watt, they're 34 watt energy savers, which saves energy, but the light quality is really poor. And they also don't work very well in cold temperatures. And the ballasts that drive these lamps, manufacturing was ceased in 2010. So you can, if you want to patch up your T12 system, get an electronic ballast that works for T12s, but I don't recommend you go down that path. And also, most of the T12 lamps, most common ones, have been phased out, and you can't get replacement lamps. The ones that you do, there's some exceptions, but you usually have to pay more for them, or you have to accept some performance or energy saving. There's some energy saving compromises with those. So if you have T12s, you need to get rid of them. But what do you upgrade to? And that's what we're going to talk about in the next few slides. Keep in mind that the T8s are smaller in diameter than T12s, but they're the same length and they have the same pins as your T12. So they fit in the same lamp holders, which makes them really good for retrofits. So any T8 with electronic ballast is going to be better in every way than a T12 system, especially with your color rendering and lamp life. But you want to choose what's called a high performance T8, which is an improved version of the T8, as well as high performance electronic ballasts that operate the lamps more efficiently. So combine these and you get a high performance system. When you do this, savings of 40 to 50% is easy and common. And in our service territory, they're required in order to get an incentive from Energy Trust of Oregon. And the place to find out which lamps meet this criteria is on this website. So another type of high performance lamp is called a Reduced-Wattage T8. Now, if you already have an existing T8 system and you have 32 watt T8s, you could replace these with either 28 or 25 watt lamp in many cases. And you can save around 10% by doing that, just by relamping. But you need to keep in mind that this lamp needs to be in conditioned spaces or used in an enclosed fixture in colder spaces. So this is especially good strategy if you're overlit. So the energy usage and light output is reduced by about the same amount. But where you can save the most energy is where you use this lamp in a retrofit situation, which you would have to do if you had an existing T12 system anyway. You couldn't just relamp with these because it's not compatible with that old magnetic ballast. It's also good for retrofitting when you have an older T8 installation. This is because the ballast is now nearing end of life. It needs to be changed anyway. So you might as well get a new lamp as well as a new, more efficient electronic ballast. But before you go the reduced wattage T8 route, look at the full wattage 32 watt T8 lamps first. And this is because they have more light output, and you might be able to go from 4 lamps, let's say, down to 2 lamps, or maybe even just 1 lamp. So the fewer number of lamps is better, more sustainable, and easier on maintenance and lamp replacement costs. So to maximize the retrofitting of your recessed troffer, which is a very common fixture, is you can retrofit with a kit. Instead of using existing lamp holders, you're going to get something that looks like this. It has new lamp holders, and what it does is it repositions those lamps to the center to be more centered, so you get better light output. Now you can improve on that by having a kit that also comes with a reflector, and very often you might want to get a new lens as well. And speaking of lenses, they make advanced lens retrofit kits. You get all the hardware on the left, plus you have a more efficient and updated lens. So it not only looks better, but it performs better. So since I can't take every one of you out in the field and look at some actual fixtures, this is the next best thing. So take a look at this picture and see what you can find that gives you some clues about whether this fixture can be saved or not, or what's been going on. One of the most obvious things, to me anyway, is that you have lamp holders with no lamps. So this probably was overlit, or perhaps one of the 2 ballasts. In this ballast cover behind here, there's 2 ballasts, because a magnetic ballast can only operate 2 lamps at one time, where an electronic ballast can operate 4 or even more lamps at one time. So it could have been overlit. You'll see that the surface of the housing is very discolored. It's dirty, so it's not reflecting very much anymore. You'll see that the lens is missing. You see that the hatch here is not closing all the way. That's probably because one of these latches has probably broken off. A lot of times these are plastic, and you can't keep that lens cover closed anymore. So this is a pretty bad situation, but you could still retrofit this. So think of your application. What would you do with this? Would you just simply relamp and reballast? Pick one of these lamp holders and put a new lamp in here? Would you put a new kit in here that would reposition those lamps? And how about a kit that had a reflector? It would certainly get a lot more light out of this fixture than this dirty housing, unless it could be cleaned up quite a bit. Or would you get an entirely new fixture? So different applications, different situations are going to require a different decision. So what about T5s? They're thinner, they must be better. Well, there are two basic types. One are standard T5s and one is a high output version of T5s, known as a HO, high output. But they don't fit in the T12 or T8 lamp holders that we talked about. And that's because they have miniature bipins and it's also 2 inches shorter. So this is not meant to be a retrofit lamp. It's best when used in new fixtures. So these are some of the best examples for using T5s in an indirect fixture, especially when you can put the lamps end to end, maximize your fixture efficiency. In a fixture that has an advanced lens, and then high bays. This works really well. You can replace your metal halide and high pressure sodium with a high bay that has fluorescent lamps. So keep in mind that even though we're talking about T5s, these applications can also use high performance T8s. And in many cases, that would be a preferred choice over T5s. Now let's say you have an industrial fixture that, here's a cross section here, and these are 8-foot lamps. And they could either be your basic slim line that has a single pin, or you can have the higher lumen output lamps, HOs and VHOs. And what you'd want to do with these, if you come across these, is that you want to replace each of these 8-foot T12 lamps with 2 4-foot T8 lamps, as we see in this illustration. What you're going to do is you're going to get this kit that looks something like this, and you're going to have new lamp holders here and also in the middle that allows you to put 2 4-foot lamps where you had an 8-foot lamp before. So the 4-foot lamps are the better performing lamps. And you can also reduce your lamp inventory, and you don't have to carry around these awkward 8-foot lamps. But sometimes it makes more sense just to put an entire new fixture in rather than retrofit. So here's an example of what this looks like. And some of the clues here, you've got that reflector that's really dirty. This lamp holder is being pushed out. Sometimes the lamps actually even fall out. You're getting a clue that these lamps are pretty old. Some of the tungsten filament in these lamps ends up on the lamp wall and darkens it. That's a good clue you have an old lamp. But you can take a kit that will take this reflector off, the lamp holders, everything except this channel, and you attach this new kit and it looks just like a new fixture. But again, sometimes it makes sense just to simply hang a new fixture. One reason to put a retrofit is that the retrofit technician is going to be cheaper than having to hire an electrician to install a new fixture. So in summary, get rid of the T12s, always use high performance. Look first at your full wattage 32-watt T8s before looking at reduced wattage, which could certainly be a good option. Rule out retrofit options before getting new fixtures, and decide if lower light levels could be appropriate. And then if you have very long hours of operation, an LED Troffer upgrade might be a good idea. So speaking about LEDs, we already looked at directional lamps and why they're such a good LED application, but recessed cans are also an excellent application. LEDs work here really well. LEDs like it cold, so your refrigerated display cases is excellent. Same thing with outdoor signage. And this can be especially good. LEDs could be good because of maintenance reasons for these signs also. Recessed Troffers, we've kind of touched on those. Fluorescent is the best choice right now unless you have really long hours of operation. And there's some outdoor fixtures that recently qualify for some energy trust incentives, parking garage, gas station canopies, and some of your street and area lighting. And don't forget your exit signs. Now, some good applications: as the cost of LEDs goes down, the performance goes up, you're going to see more outdoor fixtures, some of your fancy architectural types, and ones with the higher wattages will be more cost effective. And again, with long hours of operation, high bays can work. And we're just starting to see some good LED indirect lighting. Now, for more detailed information, I give a webinar on LEDs, and we're also having some seminars coming up in September that will talk about LEDs in much more detail. So let's switch gears. We're in the home stretch, and we'll look at lighting controls. Because of limited time, we're just going to talk about occupancy sensor controls today, and these turn off the lights or lower light levels when no one's around. Many people have had bad experiences with these sensors in the past, but trust me, they're getting smarter, more reliable. So give them another chance. You need to pick the right one for your application. Here we have one that replaces a wall switch. This type would go in the ceiling, and this one would attach directly to a high bay fixture. So one of the more common types of operation is passive infrared, and this needs a line of sight in order to detect occupancy. So this can be either a wall switch, again, or a ceiling sensor go right on a fixture. But sometimes as you get further away, they don't see small movements, so sometimes they can be prone to false off. So sometimes you have to do the big wave. Another important distinction with these sensors, actually any of these sensors, is you're hearing this term vacancy sensor. Now, a vacancy sensor is one that has a manual on feature. It doesn't automatically come on, but both the vacancy and an occupancy sensor will automatically shut off. And the passive infrared is the least expensive model. Your ultrasonic, this uses sound waves, and it's most sensitive to movement toward or away from the sensor. Now, because the sound waves can leak outside of the coverage area, they're prone to false on. Sometimes they'll turn on when they shouldn't. So these are best for rooms that have a door that's normally closed. And these are more expensive than passive infrared. And here's some applications where this sensor works really well. Now, sometimes you need better performance. You want to limit those false ons and false offs, so you can use both technologies. So the lights will come on when both technologies detect your presence. But only one of these technologies will keep the lights on, so that reduces the false offs. However, as you can expect, this would be the most expensive sensor. Some of the applications where you see this used: classrooms, conference rooms, and restrooms with stalls, or any room with obstructions. Now, one technology I'm really excited about is wireless sensor. These are becoming less expensive, and it's a great retrofit option because it avoids the cost of running new wiring. And there's an excellent incentive for this. So there's two ways to get power to these sensors. One is with a long life battery. Lutron is an example of someone who uses this technology. Some have self-powered switches and sensors, and Leviton's an example of that. So if you've not put sensors in certain areas because it was going to be too expensive to wire it, look at these wireless options. So how much can you expect to save with sensor? Sometimes it depends on the ownership of the space. If you, for instance, if you have a private office, the savings might not be as much because you might just turn the lights off yourself, all the time. You just are in the habit of doing that. Whereas if you go to maybe a conference room you're not familiar with, you don't know if you should turn the lights off or not. So they tend to get left on, and sometimes there's a big gap in between meetings. An example of an application where you have huge savings is warehouses. There's areas of warehouses that might get visited once a week, but the lights are on all the time. So to summarize controls, at least occupancy sensors, they work really well, but you have to get the right type of control, use the right technology, also put the switch in the right place, install them correctly, make sure they're pointing the right direction. That's very important. And then commission them, and that means that you can make adjustments. These sensors, you can adjust the timeout, the sensitivity, and also it's the field of view. So you can get these to work like they're supposed to work. And if you want more information, this website is excellent, the Lighting Controls Association. Tons of information, some classes that you can take at no charge. Okay, so now that's been a lot of stuff, but hopefully most of you are thinking of some energy saving opportunities at your facility. And if you want some help, your best next step could very well be contacting PG for some help. And if you have a commercial application, contact Paula Conway. For industrial customers, John Maloney. Now, if you're not a PG customer, contact your local utility and get available resources there. But if you do have Energy Trust, here's some examples of some prescriptive incentives. There's some very excellent incentives still for your high-performance T8 upgrades. We already talked about the recessed downlights and the screw-in power lamps. There's prescriptive incentives for your outdoor light fixtures. And good incentives if you want to upgrade using Troffer kits, either fluorescent or LED. And lighting controls, which we just talked about. Great incentives for that. And if you find something that's not on the list, such as high bays, you can get a custom incentive for that. To qualify for an incentive, the payback has to be greater than a year. You have to save at least 25%, and it needs to be cost effective. You also need to use approved fluorescent products, and here's that Consortium for Energy Efficiency website again. If you want to find qualified LEDs, go to the Lighting Design Lab website, and you'll find all the lists that you need to find a qualified LED. Most importantly, if you want an incentive, make sure you get your project pre-approved. So to summarize, if you have some older linear fluorescent systems, you can upgrade these with your high performance with electronic ballast, perhaps a reduced wattage lamp and ballast, and retrofit kits with either fluorescent or LED, or maybe new fixtures. Incandescent bulbs, you've got your three choices. And if you have areas where people are gone frequently, occupancy sensors work really well for that. So there's a lot more lighting upgrades that obviously we didn't have time to cover in a 1-hour webinar. But many of these topics that we talked about today and others will be covered in some half-day seminars that are scheduled in September. And Beth will tell you a little bit about that, as well as some announcements, and we'll take some questions from the audience. Beth?
Thanks, Mark. I wanted to remind you of some upcoming webinars and seminars that we have. Mark mentioned both a webinar and seminars. On October the 3rd, we have Understanding LEDs that Mark will also be teaching, and you can sign up for that webinar and our seminars at EnergyEducationCenter.com. The upcoming seminars are Human-Centric Lighting on September the 24th in Portland and 26th in Salem, and LED Indoor and LED Outdoor Lighting on September 25th. That's 2 half-day seminars, one in the morning, indoor in the morning, and outdoor in the afternoon. So we hope that you can join us for those. Before we proceed to the question and answer portion of the webinar, I'd like to remind you that you can continue to submit questions to me, the host, through chat, and I'll ask them of Mark. And I'd like to draw your attention to a feedback poll that I just opened in the bottom right-hand corner of your screen. If you can take a moment to fill that out as we go through our question and answers, that would really help us improve future webinars. And now I'd like to ask Mark our first question. Mark, what is the temperature range available for LED lighting?
Temperature range for LEDs is really wide. It can be very warm. It can be warm as incandescence, and it can be very cool. So the range is at least as wide as you would have for fluorescent. It's one little thing to know about LEDs is there really is no such thing as a white LED. It doesn't come out of the circuit board as white. We get white light LEDs by using blue LEDs, and then they have a phosphor coating on top of those, similar to like you have with fluorescent. So LEDs are inherently a cool temperature source, and you need to add phosphor to make that temperature warmer. And you need more of the phosphors in order to turn that blue light a warmer color. So the lumens per watt tend to go down the warmer that the LED is. But that gap has been closing. It used to be, a really big gap. So most of the early LEDs were a very cold, very cool color temperature. But you can get a wide range, and you can actually get LEDs. You're starting to see them now that actually will shift warm, like what happens when you dim an incandescent. So we're starting to see that happening. So you can have the color temperature adjustable.
Great, thanks, Mark. Our next question is, what about outdoor lighting controls? Is there a way to replace standard pin timers to adjust for different day duration over the year?
Well, for outdoor lighting, there's a couple ways you can control the lighting. One is with the photosensor, and that will turn the light on automatically when it gets dark, and then it will shut off again when it gets bright again. Another way you can do that is with the timer, but your standard timer, you have to adjust it frequently because, as you know, especially right now, the length of the day changes pretty dramatically. So you're going to have the lights coming on and off at the wrong time. So the way you can get around that is you can get an astronomical time clock, and that automatically, once you set it up, it knows what day it is, and it will automatically adjust its on and off times for that particular day. And sometimes you can combine a photosensor with a time clock of some kind. So you could have the lights come on when it gets dark, but say from midnight to 5 in the morning, you have no need for that light, or you want it at half level, for instance. Then your timer kicks in and shuts that light off or dims it for that period of time that you don't really need it on. And then you can also get occupancy sensors. They're starting to see those more for outdoor lighting, so that they only come on if somebody comes by, or they change light levels when somebody comes by.
Thanks, Mark. And I think our last question, possibly our second to last, but our last question is, if T8s can last 50,000 hours, do ballasts last longer, and how much longer?
Well, we are seeing, I may not have mentioned that today, but the lamp life for your T8s has gotten really long. You can get lamps now that can even last up to 80,000 hours. And most ballasts are rated for that. So you may end up getting a fixture and just lamp it once, have the lamp and ballast go out about the same time. So ballasts generally last longer than lamps. However, the most common lamps that use are probably in the 30 to 40,000 hour, and your ballasts are going to be lasting from 50 to maybe 70,000 hours. And how long those ballasts last has a lot to do with temperature. The hotter the environment, the quicker that electronic equipment is going to fail.
Great, thanks, Mark. And that was our last question. I'd like to thank all of you for joining us today, and we'll stay online a little bit in case any of you would like to ask any additional questions. But thank you again, and we hope to see you at a future webinar or seminar.